Welcome back to Hands-On with Reinforcement Learning. We're the last video of the Multi-Armed Bandit section. In this video, we're going to train the agent that we have created in video 2. We're going to let loose the agent on the environment to understand what it has learned, and also more importantly, to understand what it has learned the right thing. Specifically in this video, we're going to look at how to write a training loop for the agents in the MAB environment. Now this corresponds to the last section in CartsPo v0, where we talked about the step loop in OpenAI Gym. Very similar to this and what we're going to do in this video. The difference is in the OpenAI Gym, the training loop is for a full-blown reinforcement learning problem. Therefore, it's very complex and has a lot of information. In this video, we're going to have a very simple training loop just to introduce you to how you can expose the agent to multiple episodes of the same environment so that it gets smarter and smarter in every single iteration. The second thing we're going to do is to understand what happened after training the agent. So now we have our agents class and our multi-armed bandit class. Let's go through how we actually put this together so that the agents can go through the multi-armed bandit environment many times and calibrate the policy of which it picks the arm so that it picks the best arm every time. In the first line here, much like our CartsPo environment, we're going to create a multi-armed bandit environment, the one that we've programmed above. We then created an agent that can take in the observation of what happened before and pick the next best action that the agent thinks it can do, and also take back feedback from the environment to retrain its policy network. So then we have a very simple parameter of num episodes, really just for housekeeping. We're doing 50,000 iterations through the multi-armed bandit environment, and the epsilon for picking whether they should explore or exploit the current knowledge of the agents is 0.1. So much like all TensorFlow computations, we need to create a new session so that we can allocate this computer resources to the agent. We run global variable initializer to initialize all the variables that we're using in the agent. And we then go through all the episodes, and for each episode, we ask the agents to poo one of the arms of the multi-armed bandit environment and get the reward. With that, we can record what action or which arm was pulled and what was the reward, so that the agents can use this information to come up with the best policy. At the very end, we're going to print first the best bandit or the best arm to pull, and then we're also going to print the prediction from the agents which arm it thinks is the best. And if these two numbers match up, then it means that we've got a successful run. Great. So this wraps up the section. Let's summarize. So in this section, we went from CartsPo v0, which looks simple on the surface, but is actually quite complicated in terms of the information that it's giving you. We went from that quite complicated environment, and we went back down to multi-armed bandits, which is an environment that's quite simple. And the idea there was to allow us to focus on understanding how we can train an agent. And because the whole thing is simple enough, how we can specifically train an agent to produce the best policy within the environment. So in this section, we created that bandit with 4 arms using Python and NumPy. We also talked at length about how multi-armed bandits relate to the CartsPo environment. And then we created an agent to solve the multi-armed bandit problem using Python and TensorFlow. And again, TensorFlow is important here And if you don't have a TensorFlow background, I encourage you to go look up some simple tutorials. But TensorFlow is important here because reinforcement learning has been in the spotlight recently because deep learning models provide very good mechanisms for researchers to train better agents. And so deep learning and machine learning and models like neural networks rely a lot on automatic differentiation packages, and TensorFlow is one of the best. In the last video, what we did was to train the agents and understand that it actually learned, and it learned the right thing. And that's very important. Very important concept in almost any research is to start very, very simply, like what we've done with multi-armed bandit, to make sure that you actually understand how to create the right outcome. In this case, the agent learns the best policy. And then from there on, we can then stack up and have more complicated things. In the next section, we're going to ramp it up and not only have one multi-armed bandit, but actually have a few multi-armed bandits. And the task is for the agents to know bandit that it's facing, what's the best action.